We're going to be talking about fronts today. And in order to understand fronts, like a warm front, cold front, we need to learn a little bit about the air masses that collide and make these fronts. In a war, the front is where the action is. The generals, the presidents, they're not on the front. The soldiers are on the front. And when it comes to weather, where a warm air mass and a cold air mass come together, that's what we call a front. That's where the action is. So we're going to look at the characteristics of air masses today. I have two colors of Jell-O. I have orange, some orange Jell-O, which is going to represent one type of front. And I have some green Jell-O, or one type of air mass. I have some green Jell-O, which is going to represent another type of air mass. So what we're going to do is discover the characteristics of these air masses. We're going to play around with the orange and the green Jell-O and see, make a list of what are the characteristics of the green Jell-O and what are the characteristics of the orange Jell-O. So let's start with the green. I'm going to pick up the green air mass. You can see that that's kind of falling apart. I'm going to try and stack some green Jell-O on top of other green Jell-O. And it kind of is unstable. It kind of falls apart. The green Jell-O, I'm going to try to push some orange Jell-O with the green Jell-O. I'm going to try and push it along. But as you can see, what happens with the green Jell-O is it kind of can't push the orange. It's just not quite strong enough to push that orange along. So the green, you can use a lot of different words to describe it. It's literally falling apart in my hands. It's not very dense. It's not very stable. Now, let's look at the orange. The orange represents the other type of air mass. There's warm air masses, there's cold air masses. Again, when these come together, we get a front, and that's where we get weather. Okay? Look at this orange Jell-O. I'm twisting it around. I'm stacking it up in piles. I can even tear it and stack it, and it just tears right away. I can pile it up. Compare that to this. This really seems much more stable and dense, less crumbly. There's a lot of ways that you can talk about it. I'm going to take one of the orange Jell-Os, which represents a certain type of air mass. I'm going to put some wet. And now I'm going to get a fresh green, because the green, I had to make two containers of the green because the green just kind of falls apart. Look at it. Look at this versus the green. Now, if I take the orange and I try to push the green, the orange can just push that green right out of the way. It seems to have much more strength or much more ability to push. Remember when I tried to push the orange with the green? The green just kind of like went on top and fell apart. The green cannot push the orange. These air masses have different characteristics. Okay? And one of these represents the high pressure air. Remember that high pressure meant low temperature? So either orange or green is cold air. The other one was a low pressure, where we had very warm air. And remember, that warm air rose into the atmosphere. The warm air, it's just not able to do much but go up into the atmosphere. So if I was to ask you, which one of these air masses do you think is the cold air which would sink, which is stable, which is more dense, which color would you think would be the cold air? And if I was to ask you which one would be the unstable air, the air that rises into the atmosphere, the air that can't push the other one out of the way, that would be the green. So we've represented cold and warm air using Jell-O. I made this Jell-O a little bit different. I took a little box of Jell-O. In this one, I only used a half a cup of water. And in this, the same size box, but a different color, I used 2 cups of water. So this has more stuff in it, more dense. Remember that high pressure, that cool air that's falling, more dense. So let's look at our screen, and we can see that these air masses, warm air masses, cold air masses, these are what causes our weather. Air masses are large bodies of air. We're talking about 1,000 miles, 1,000 miles or more across. We're talking about very thick, a kilometer. We're not talking about a little cloud, you know, over a little pond or something. We're talking about a huge amount of air. Within an air mass, there's the similar types of characteristics, dense, cold air, or dry air, and it all depends on where that air mass formed. Okay? You can see that this cold, dry air mass that formed over the land in Canada, as it travels, as it makes its way down south, it has a chilling effect on every single city that it passes. Now, we know about air masses. We know where there are. We have not figured out, why do they start moving? Why isn't this happy just staying up here? Especially in the winter. We don't want this cold air mass to come our way in the middle of winter. This freezes us out. You can see, even down in Texas, it's very, very, very cold. So, air masses are named and characteristics by where they start, where they originate. We've got polar, 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 polar. So if they originate in the north, they're polar. Tropical, tropical, tropical. If they originate in the south, they're tropical. So we've got CP, continental, ones that originate over land. They're going to be dry. This is dry and cold, dry and cold, dry and warm. And we've got maritime. That's an old-fashioned word for water. We have a maritime sailors' cathedral in downtown Detroit. That's for the sailors coming in on the big freighters to go to church when they're in town. So maritime, maritime. So if it's over the water, forms over the water, it's going to be warm. It's going to be moist. If it forms over land, it's going to be dry. Forms in the north, it's going to be cold. Forms in the south, it's going to be tropical. Now, what does that have to do with us? Typically, our weather is caused when this warm, moist air from the south and this cold, dry air from the north meet. That would be a front. And depending on what air mass is moving, if the green air mass, or the orange Jell-O, if the orange Jell-O is moving, it's able to push that green Jell-O right out of the way. If this is moving, it's going to just sit on top. If this air is moving, we call it a cold front. And if this air is moving, we call it a warm front. And we saw the characteristics, and so if you look at when you've got a warm front, which you'll see these on the map, these semicircles, when you've got a warm front, the warm air is moving, could the green push the orange out of the way? No. It just sits on top, so when we have a warm front, and the warm air can't push the cool air out, and this is when we have precipitation over a long part of the country. We can have rain in Detroit, Chicago, St. Louis, we can have rain for 1,000 miles because we've got this interaction. Where cold and warm comes together, we learned this in our clouds lesson, that's where you get the rain. But when you look at the cold, that orange could simply plow through the warm. When that happens, when cold air is on the move, we have these cold pointed triangles here. When cold air is on the move, we get heavy precipitation, we get quick storms. But after it passes, we get nice, cool, we get a nice cool down. Especially in the summer, we welcome a cold front. We're getting one tonight. Right now we're getting southern wind. It's 90 degrees out, very humid. Tonight, cold front's going to come through. We may or may not get thunderstorms depending, and it's going to cool right down. So looking at the characteristics of the air masses, you can see how interactions can lead to different types of weather.